Hardware interface standardization and cloud infrastructure, the road to rapid integration of lab instruments and robots. There it is. So as we noticed in quite a few of the presentations, connectivity is a huge issue. So when you're talking about LIMS systems and schedulers and all the software you have in your lab, usually when it comes to specific devices, you have the problem that you need to integrate them. And currently, the hardware vendors are usually not really supplying you with the standardized interfaces that you would need to do that. So where does this journey start? First of all, I'm Lukas Bromig. As mentioned already, my background is actually in chemical engineering and bioprocess engineering. And how did I get here? I did my PhD project at the Technical University of Munich on the topic of digitalization in industrial biotechnology. And why is this relevant? Back then, we were basically given a brand new lab with lots of devices, pipetting robots, bioreactor systems, peristaltic pumps, precision balances, everything. And the goal was to accelerate the entire R&D process, to speed up the development part, from the screening processes to the development and optimization of the processes all the way to downstream. And there we collaborated with the research center in Jülich and the Leibniz University in Hanover. It was a BMBF-funded project. And what we realized in the very beginning that we had to figure out how to communicate with all these devices in a uniform manner. And that's how Sila came into the equation. We were part of Sila and still are as an academic member and helped there to actually shape the standard, build implementations that you can build these interfaces. And well, now a couple of years later, we were able to basically use these interfaces over and over again for a multitude of academic use cases. And how does standardization help us to build a sustainable infrastructure in our labs? Well, this is kind of what we came up with. We basically decoupled the integration part from the actual software, the application logic. So what I mean by that is usually you have a LIMS system and you do a one-on-one integration of your device into that software. And then, for example, if you want to change your LIMS or if you want to access this device from another software, you actually have to do that integration over and over again, and it binds resources either internally or you pay a consulting company, but it's always very expensive. So if you decouple that and basically establish some sort of middle ground, you can circumvent this issue. And Sila actually helps by doing that. So a lot of the legacy systems, for example, we could upgrade with connectors, with little microcontrollers. And we built servers, Sila servers for that, so we could connect and talk to the devices. Nowadays, actually, hardware vendors are picking up the pace and are actually building Sila native devices so that they are already initially compatible with lots of devices. This is actually the architecture that how we, as UniteLabs, now basically developed what we built at the university as a prototype into a product. So we actually have our connectors. These connect to the respective devices bidirectionally, so you can either access the data or control the devices. So this is already a step forward, because if you now are looking at just data automation, and then want to go for full process automation at a later stage, you already have a full connector at your disposal that you can use. And then once you have this integration layer, you can then basically use this API, which is then either Sila or just a regular REST interface, to integrate these devices quickly into your other systems that you have and make these connections. What does it actually look like? So thanks to standardization, every interface is interpretable generically. So as soon as you connect the system to this basic layer, you can see all the meta information about this device, and you can interact with it and execute commands interactively. But not just interactively, since this is a nice interface, you actually also have an API, which in our case sits in the cloud, but could be local as well. And then this API you can then use with any programming language to integrate it either into your workflow editor, into your scheduler, into your LIMS system, or basically just use a coding environment and use it directly. So back at our chair, we actually used a coding environment, Jupyter Notebook. Many of us probably know it. And the nice thing is that you can just import your device and then use your pipetting station in the same way that you would use your peristaltic pump, that you would use your mobile robot, and so on and so on. So this is basically homogenizing the landscape, I think. The speaker from Takeda actually mentioned that. That was a nice phrase in the panel discussion. So now you have this API layer. And if you want some sort of scheduler or something, that's always specific to a very specific workflow. So building a huge application around that is not really, for us at least, not really sustainable, because they're always customer specific. But what is generalizable is the entire boilerplate around it, around the integration itself. So what could that look like? So you have some lab devices. For example, right now there's a POC running at my university where there's just a control loop with precision balances and a peristaltic pump, and basically they're both hooked into the system. We can monitor and collect the data in real time, and also use that data to actually control and recalibrate the pump on the fly over many weeks. And at the same time, since it's already in the cloud, since we have an API, we can then link it up to other software. In this case, it's an Influx database where you can also then just visualize that data. And if you scale that up, and if you implement that for all laboratory devices, you can actually gather your data in one place way more easily and way more quickly. And you're very agile in doing so, because that part is already done, and the way you visualize it is something that you can then customize. So many companies build their own visualization tools using JavaScript or like predefined off-the-shelf software. Others don't, others build their own. And we basically then enable them and give them the access to get the data, to get the control over these devices. And then also, as I said, since we also can control these devices, you can then also do actual process automation. This is actually an example that we're currently working on, which we will show at Future Labs next week. But it's also the other way around. So many LIMS systems, for example, come with workflow editors. And in most cases, you can access APIs. You can make REST calls from within these tools. For example, KNIME, they're from Konstanz. From within KNIME, you can make a REST call. Or from within XLab, from MATLAB Toledo, and so on. You can basically supercharge these systems, these software systems, by actually granting them access to all the other devices, which would then be integrated by us. Because what you often have is you have a solution from a vendor, and they only supply or support connectivity to a fixed amount of hardware devices, either their own, if it's the software from their company, or the ones they partner up with. In this case, this is also decoupled, and you can access any device from within other software systems. So at our chair, we actually did quite a few use cases with this. Some involved pipetting stations. For example, the first one where we had like a parallel bioreactor system on the liter scale. Then we had a transfer with a peristaltic pump into a liquid handling station, which then transferred the volume into 48 milliliter scale bioreactors, which were then measured online from with a sensor bar from yet another company. So we had up to 8 different vendors basically interacting, and we orchestrated all that by having this integration layer and then just writing the application code on top. We also had some other examples here, but bottom line is they were all different, so we had to be flexible in a way. So we recycled what was kind of like the common ground, something that didn't change, and then just applied the application logic every single time. Because that is something that changes over time, that's something you want to optimize, and that's something you also want to have in-house. That's something you don't want to outsource, at least not in the long run. Right now, our roadmap is that we're currently running some proof of concepts at the Technical University of Munich, where we just try to establish that we can run long-running applications within the cloud, and that everything is robust and stable, because at the same time we're also collecting logs from everything. Every single call to every single device, every parameter that's changed is recorded, everything. So we're currently figuring out if that actually works. And we're actually revealing the platform, which is basically just a subscription-based SaaS tool. You basically just sign up, and then you can already connect your first devices and play with them from within your own browser or cell phone. And since you already noticed, the bottleneck here is the actual connector. Getting the connectivity to those devices, building the Zila servers, is something that is kind of like limiting. We're also launching an open access connector sharing platform because the community, the Zila community, is quite large, and a lot of servers are being built in academia, in Greifswald, in Adam Wolf is building some, I have built some, even some bigger pharmaceutical companies have entire full-time equivalents just building these servers. And what we're trying to achieve is to actually make this more accessible, that people share these integrations, because this is something that would also help us in a way, because as soon as they speak Zila, they're compatible with our software, and you would have access to them immediately. And yeah, at the same time, since we are a cloud platform, we actually use Zila 2 1.1, which is basically the cloud connectivity use case, where the actual device server, the driver, some call it, that is on-prem, automatically connects to a client in the cloud. And we actually built a new reference implementation that makes it incredibly easy for even non-software developers to write these connectors. So in the long run, it would be quite nice that even the end user could just quickly write a Zila server and then make his own device or some other software server available and accessible in the cloud without having, like, I don't know, year-long consulting projects. So yeah, next week on Wednesday, we're at Future Labs Live, and we actually have a nice exhibition there with some hardware vendors that we collaborate with. Because as I mentioned, some hardware vendors actually built these standardized interfaces themselves already, and the more customers actually ask them to do so, the quicker they will actually do so. So if you're a customer, ask your hardware vendors to supply you with a Zila interface. That makes things so much more, so much easier. Yeah, so at Future Labs we actually have like a nice workflow with a robotic arm, with a plate reader, with an open trans pipetting station and an incubator. And actually, since we have this infrastructure in place, writing the workflow and orchestrating this is just a matter of hours and not months. So yeah, I would love to see some of you there. And yeah, that's it. Thanks for your attention.